Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our D programming language series. In this lesson, we're going to be talking about some of the loop constructs that are available in the D programming language to allow us to, well, affect the control flow of our overall program. So we're going to talk about for loops, while loops, do while loops, and we're going to leave you on a little bit of a cliffhanger. There are for each loops available in D, but you're going to have to subscribe and see that specifically in another lesson, because I've got to talk about ranges a little bit more for us to understand exactly what for each loop is doing. But with that said, though, let's go ahead and cover the basics, and I think you'll enjoy this lesson regardless. So with that said, let's go ahead and open up a programming file here. I'm just going to open up the file for main.d, and you're going to see that it's empty here. Now, if I'm writing a program, and a particularly large program, let's say that I've got some variable here. I'm just going to call it counter, for instance, and set it equal to 0. And let's just go ahead and write out that value here. Okay, and I'm going to go ahead and run this program here. And of course, it prints out 0 here. Now let's say that I want to do this a few more times here, updating the counter. Maybe it's counting how many times right line, for instance, has been printed out. So I could do something like plus plus counter in this way. And let's go ahead and just see what this does. So again, something new in the series, we can do this prefix, which updates counter and then writes it out. And just to make this simple, in case you're not familiar with that notation, let's just do counter plus plus after, right line, counter. And I'll go ahead and run it, and we'll see the value 1 again. And let's say, again, we want to repeat this code here because we thought that was useful, and repeat it again, and repeat it again. And I'll run this program, and you get the idea. We're counting 0, 1, 2, 3, 4. Now, what if I want to do this 1,000 times or 1,000,000 times? Now, certainly I could copy and paste, and an editor like Vim that I'm using will allow you to do this, but it's going to take a really long time, and what if you modify the code? So of course, programmers way long ago, when programming was invented, came up with some of these ideas for us to be able to move back and re-execute a piece of code. So if I just go ahead and model what a loop is doing, we have some statement here, like write line, and then something that we want to execute after. In this case, we're doing counter plus plus, right? And whatever we're writing out here. And the goal is that we want to be able to repeat this work over and over and over again, each iteration of our program. Okay, so that it's doing this series of statements without having to type them out. And this is a sort of control flow or logic that programming languages like D and many others that you might be familiar with have. So things like loop constructs. So what we exactly do with a loop, or how it's structured, is we have some keyword here. And the first one I'm going to show you is called a while loop. That's going to evaluate some condition that must be true. And this is just like what we learned with the if conditions in the previous lesson, so make sure that you watch that. That's going to say, hey, if this condition is true, then go ahead and execute this statement, and then revisit this condition, check if it's true again, and if it is, then we execute this line, followed by this line, and so on. Okay, so that's how a while loop works. And then we do have some constructs because eventually we might want to break out here. Because depending on what this condition is, it might just always be true, or, so we have to decide how do we actually terminate execution so that we can move on with our program down to some other block of code that will inevitably have its other loops here, and maybe we'll jump around in execution as needed here. Okay, so that's the basic idea. Let's go ahead and demonstrate it, and I'll go ahead and demonstrate it with this code that we have here, just to show what we have here. So what I'm going to do is get rid of these statements here, and I had 5 total iterations here. So that's what I'm going to sort of want to model, something of that nature. So what I'm going to do is initialize counter like we did. I'm going to say while counter is less than 5, then go ahead and write out the counter and increment the counter value. Okay, so that'll effectively do the same thing here. So if I execute this, we'll see 0, 1, 2, 3, 4 here. So each time here to step through my program, I'm initializing the counter, testing this condition. So 0 is in fact less than 5, writing out that value, incrementing the counter. And then as soon as I reach this block scope here, for our while condition, so with the curly braces, it's going to jump back up to execution to our while loop and test this condition. And if it's true, then we can execute again and proceed forward. Okay, so we can see how this loop works 5 times. Now, sometimes we might also want to break out of our execution early. So let's go ahead and do something a little bit more wild here. And let's say that this loop's going to run 50,000 times here. Okay, now if I run this, or you run this, and let's actually do maybe 5 million, your options are to either let the program run or maybe hit Control C so you can terminate your program. And that's how we would sort of manually terminate the loop, also terminating the program. But again, we want to conditionally maybe terminate this particular program here. So one thing that I can do here is I can say, hey, I don't want to wait to test this condition here, but I want to, within my actual program, come in here and say, if the counter is greater than, say, 500, then let's actually break here. And that'll actually break our actual condition here. And then we can write out, we'll just do another line here, the counter here. Okay, so this terminates this scoped loop here, and we'll terminate our loop at the 500th iteration here. Or rather, it prints it out as soon as counter is greater than 500, breaks our execution when it's 501, and then we write out the value one more time so we can see that there. So break is one of our ways to terminate a loop that we are actually executing. So that gets us out of this block scope so we can proceed on with our program elsewhere. Okay, so that's one way that you can terminate out of a loop. But oftentimes what I'll do sometimes with a loop is I might actually want my loop to execute indefinitely. So let's go ahead and set up another example here, and I'll just comment out this code for now. Let's go ahead and just use a comment here to comment out all of our lines here. And let's go ahead and create another loop here so you can see another example of this. And in this example, I'm going to go ahead and create an infinite loop. So that would be something like this. This condition is just always going to evaluate to true. So in the loop here, okay? And if I go ahead and rerun this, it's just going to run indefinitely. So I will have to hit Control-C to eventually terminate this program if I don't have any other mechanism. But let's go ahead and check conditionally something that might evaluate to false here. So the way that I'm going to set this up is I'm going to actually bring in a new line of code here. So let's import from our standard library. And I'll do this similar to what we did here. From the standard library, stdio, and I want to bring in read line here. Okay, so just like we did up here with write line, but now I can actually read in a line here. Okay, so what am I going to do is actually just create a string that holds the user input here, and then I'm just going to test what this input is. So if this input is not equal to Q here, then I'll terminate from this loop. Okay, and let's go ahead and prompt the user here, type in a letter, and then the user can type something in, and maybe we'll just use write this time, just so it doesn't put in the new line for us. And then we're going to read in our input using the new read line command that we learned about. And then we'll write out a message here, still in the loop. Okay, and I'll go ahead and put in a /n here. And let's go ahead and let's just run this with DMD, see if I made any mistakes here. And oops, looks like I made one mistake here at line 22. And let's go ahead and try again. And it looks like we have, again, one more undefined identifier here because, again, well, we haven't imported it. So at this point, maybe just to make things very simple, I'm just going to import all of our standard input and output. And we'll go ahead and continue executing here. Okay, so it looks like the program compiles, but let's go ahead and test this out and see if it's going to work here. RDMD, I'll run it, our main program, and it says type in a letter, M for Mike, still in the loop, M, I, etc., etc. And let's actually try Q. I'll hit enter, and ooh, looks like we're still in this loop here. So it didn't terminate. What actually happened here? Well, I've actually introduced a bug just because this is something common that I see students make here. So I've got to hit Control-C. I'm going to terminate this loop here. And what we want to be careful with this condition that we're testing here, because really we're just testing the first character of the string. When I hit enter on read line, it's actually putting a n line mark here. So /n here. Would actually handle this case here, okay? Because the actual key press of enter counts as a marker here. So this time, again, let's test it out with M. I'll hit Q now, and now our program actually terminates. So we have exited, okay? So that's just one way, again, that you can terminate the loop by having this condition be false here. Now, again, we can bring in what we learned before. So let's go ahead and copy this, and I'll go ahead and paste this down here. And let me go ahead and just say, for a video game or something, maybe what we want to do is just always be in the loop, so it doesn't terminate for any reason. So often this is another pattern you'll see. Here is a infinite loop here, and you'll just handle the input here, and then taking in what we learned last time from our previous lesson, we'll just say if input, and I'm going to test this a different way, just looking at the first character equals Q, then we will break. Okay, just like we learned previously before, and break will break us out of the scope of the current loop that we're in. Okay, so let's go ahead and try this just to make sure it repeats the same behavior that we had. So type in a letter, R, M, and then I'll try Q, and this time it actually terminates. Okay, so that's while loop, and that's how we terminate things. And a few different ways to use this sort of break statement into instances. Now, there are some different iterations of while loops that we can use. So let's go ahead and comment this out. We'll do another example here. And there's one that's called a do while loop. Okay, so say do while, and then some condition is true. And let's go ahead and say a counter here is less than, say, 5 here. And I'm going to go ahead and create our counter. And actually, let's go ahead and set the counter to 5. And just to, again, show you some different things, while our counter is greater than, say, -1, let's make this an integer. And let's decrement our counter, minus minus. And let's actually just write out the counter value here. And so that we do a decrement this time. Okay, so let's actually run this and see what the behavior is, and then we can talk about it here. And this time we see 5, 4, 3, 2, 1, 0, blast off, or whatever you'd want to print off in this case. But the difference here with a do loop is notice where the condition is actually being tested here. So it's actually being tested at the end. So the structure of this loop here, and I'll put this in our whiteboard here for the do while loop, is that we actually start executing each of the statements that we have here. So in this case, we are writing our line, and then we're doing our counter operation, and then any other operations that we might have. And then we're testing the condition at the very end. So here's where we're saying while some condition is true. And if it is true, then we go back to our first statement and execute it. So the do while loop will execute at least one time. Okay, so depending on how you're structuring your program, you might want some piece of code to execute at least one time before the actual test is being performed on whether we're going to continue iterating or repeating this work. So that's up to you on sort of the structure of your program, but just something to be aware of that this is available. Okay, so this is the do while loop. Okay, now there's one more loop that I want to go ahead and show you how to use. It's a for loop, the classic for loop that, again, you're probably familiar with if you're coming from a C, C++, Java, etc. background. So the structure for this one is say for some, and I'm going to go ahead and label these the initializer, this initial value that we have. And let's go ahead and just use our counter example. And I'll make this an integer here. And basically, this is initializing some variable to 0. That's within the scope of this for loop here. Some test here, counter less than 5. And what we want to do every iteration of our for loop. Okay, so let's go ahead and take a look at this. And I'm just going to write out the line here, counter. And let's go ahead and give this a run, and then we'll talk about it just to see what it does. 0, 1, 2, 3, 4. So this code here that we have, and let's go ahead and split this window just to show you that it's basically equivalent to where we started this lesson off. If I go to our very first example, which I've modified here with our counter, so we don't have it anymore, but that's the same idea. If you rewind the video to the very first example, this is doing the equivalent thing. The difference is we're able to initialize a variable, and the scope of this variable is actually just this loop here. So between this curly brace and this curly brace where we have this loop here. Okay, so counter is within this scope here that I'm highlighting. Okay, so counter isn't available here. Let's go ahead and try. Say counter equals 10. And if I go ahead and try to compile this, we're going to get unidentified counter because the scope's just right here. Okay, so that's the first thing to be aware of. The second thing to be aware of is that we have this conditional statement here. This is what we're evaluating to be true. So oftentimes you'll see something like this, but we can again use all of our constructs, and I could put spaces between these if I want, just so I'm being a little bit more clear here. So let me go ahead and just indent these so you can see them on 3 different lines. I can also do stuff like counter is less than 5, but greater than 0 or something, right? So I can enumerate on these or make these conditions just like I would in any other code. And the same here is the sort of loop statement that is executed every time. So this could be counter plus plus. It could be something more like counter equals counter plus 2. I could call a function here if I wanted, but this is something that's going to be executed every time. So the first time when we enter this for loop, we initialize this variable. So this is just a one-time thing. And then we go ahead and, well, let's look at our code. Let's see, did it execute the first time without testing the condition? Let's go ahead and run it and see if that was true. Main.d, and it looks like it does, okay? So it just starts initializing, okay? But let's go ahead and see if this is ever going to execute if this condition is false here. Okay, so let's say if counter is less than, let's say, or when this should terminate, let's say if counter is greater than 5 here. Okay, so previously this was executing when counter was less than 5. Well, let's just go ahead and flip the condition here and see if this works here. Okay, well, it doesn't work. So again, similar to the do while loop, again, we're reading our code from top to bottom, left to right here. Initialize the variable, so counter is 0. Test the condition, okay? And, well, what about this? When does this happen? The counter plus plus. Again, let's take a look here. So this time we want the loop to actually execute. So it looks like this loop statement, and I can confirm this because I know, is evaluated after our first iteration of the for loop. Okay, so let's go ahead and take a look here. Let's give ourselves just a little bit more room here for our for loop. For loop. And the basic idea is our for. So this is, we initialize some value. I'm just going to abbreviate this. Initialize our value. Test the condition. That's the next part. And then we execute some statement here, which is write line. And then we call our loop statement. Okay, that was this part, counter plus plus. What do we do after a successful iteration of our loop? And then we go back here and test our condition. Okay, we've already initialized our variable, so that only happens one time. Okay, so just something to keep in mind. And this is the same functionality in C and C++ as you would see. Okay, so if you've made it this far and you want maybe a little bit of a bonus, again, maybe you've seen this before, something to be aware of is that you actually can get rid of these statements. They're optional to say. So I could, move counter plus plus here because, maybe I want actual control of where counter plus plus is operating. So this is effectively the same thing that we just had. So let me show you that this is equivalent to what we have here. But maybe for whatever reason, I want, this part of the loop statement that is going to have here to execute first for the counter, effectively giving me, the iteration or updating count before I write out the value here. That could be up to you, for instance. So you just have to think about that when you're actually executing this code. All right, so sometimes you'll see folks who just use for loops, or sometimes it just makes sense to do that. Again, if you wanted an infinite loop here, you could leave these as blank here. And you'll often see this. Let me get rid of the spacing just so you'll see what it looks like. It'll look something like this here. Okay, so that's the idea. Let me go ahead and put these here because I think this is the nicer way to write this code. Something like this would be fine. Again, usually you'll find these things on the same line. Okay, now we're almost done, but I want to go ahead and show you, again, the most common way that you're going to see for loops for now in the D programming language. And let's go ahead and comment this out so we get a new example. And let's go ahead and put together something that we've learned previously with an array. And what I'm going to go ahead and do here is just call this values And let's just go ahead and put in some values here, 1, 2, 3, 4, 5. And let's go ahead and use a for loop here. And what I'm going to go ahead and do is say for uint counter equals 0, while counter is less than values.length. And let me make this just a little bit bigger for our indentation. Each time I'm going to do counter plus plus, and we'll just write out the line here, values at our counter. Okay, and let's just go ahead and run this code here. Whoops. And I love when I make a mistake because the D language provides really good error messages many of the times here. So this is just a little spelling mistake here. Have no fear. There we are. All right, so let's go ahead and give this a run. And you can see 1, 2, 3, 4, 5. Okay, so what's new about this example is, again, I'm using a property of our array here that we've allocated to say, well, this counter is less than the length here, increment the counter. And again, the pattern that you're most often going to see for these types of loops. So let me go ahead and just do a substitution. You will often see I instead standing for index. Or let me go ahead and undo that change here. The other common way you'll see it, depending on your domain, something like IDX, again, short for index, when you're just indexing into array here. Okay, so this will do the same exact thing. Let me save this code just to show you that it works. And there you have it. This is using our loop here. And just a little few bonus tips on notation. IDX or I are going to be your indexing variables. And again, because the scope here of this variable is only to this loop, I could do this multiple times. So let's say for whatever reason, I have to iterate through this collection again. This is how I would, again, be able to do this twice with 2 loops. And we can see that's running 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 again. Now, again, just as you're testing this, or if you're learning this, it's probably more useful to, give yourself some weird numbers here. So try something like that. And again, you can see that the numbers are, again, iterating 5, 3, 4, 8. And you see that that happens twice here. 5, 3, 4, 8. Okay, and there are some other tips on how you actually want to write these loops here, but this is where we're going to come into for each, and that's going to be in a later lesson because that's going to have to deal with ranges and actually iterating through different types of collections. If you're truly intending to look through the actual length of something, you probably wouldn't use less than here. For instance, you might use not equal to length -1 or something of that sort here. Again, just to better show your intent. But we are going to have another tool for it. And regardless, for loops are useful for these types of iteration. All right, folks. So with that said, I hope you enjoyed learning a little bit more about control flow with the loop construct and how to break away execution if you need to. Now, just as I'm saying this, there is one more thing that I need to show you before we wrap up this lesson. So again, if you've hung around this long, thank you for that. Let me go ahead and just show you one more thing here since I've got 2 versions of this. There is one other thing that we can do to sort of shortcut execution. So we learned about break before, which breaks us out of execution. But there is something called continue here. So what this will do is effectively, as soon as I execute continue, it won't execute this particular value. It'll jump up here and do our, loop statement and then test the condition immediately. Okay, so that's what continue is going to do. So let's go ahead and just run this to see what happens here. So I run this time I only get 1 execution of this for loop. And this one with the continue statement just says, hey, no need to continue further down to the rest of this code here because I'm just saying continue. So again, jump back up here, execute the loop statement, and then test the condition here. Okay, so had to sneak in continue there before I got us out here. And oftentimes when you want to do this, let me provide a more concrete example. So I'm going to go ahead and comment this out so that we have all of our examples. And let me go ahead and just show you an example of where you might use this continue statement here. So let's go ahead and create some string here. I'm just going to call it text here. And I'll just call it, Mike here. And what we're going to actually do here, I can use the for loop here. And my goal here, the task, search for the I character. Okay. And we just want to see if this is actually found in the string here. Okay, so we'll talk more about functions and these types of things in the deprogramming language, but let's just go ahead and write it as a loop here. So I'm going to say at some index here, starting from 0, while index is less than text.length, and then we will increment our index. Okay, that's the idea. And again, let's go ahead and make this a little bit neater for you. So each separate line here. And what I'm going to do here is, again, check every character. So I'm going to say, hey, if the text at the index equals I, then we'll go ahead and be done. We'll say found it. And let's go ahead and then what we want to do here is, for instance, break our execution so that we terminate early. Okay, so that was one of the things that we learned about that we can do here. And it looks like I'm missing one parentheses here, or excuse me, have one extra semicolon by my parentheses. Let's go ahead and get rid of that. And then we could say we found it. So we would use something like break to have a sort of early execution, for instance, or early exit, okay, when we find something. Okay, so where would we use continue to do some work, for instance? Well, we could sort of inverse the condition here and just say, well, if the text is not equal to I, then we want to continue here, okay? Because that was our interesting character to find here. And then what we would do down here is just say write line, found it, and then I could also just write break down here. Okay, so this is effectively the same program here. So let's go ahead and recompile, rerun this. And again, we'll see found it here. Now we have to think a little bit about how this is working, but this is just sort of an exercise of our control flow, where I would say, okay, if the text is not equal to I, if there's any work here, which in this case, the work that we're doing is just printing found it, then, well, just go ahead and jump up here. Again, execute our loop statement, test our condition, and then come back and then start executing this code. Okay, so we sort of short circuit or just continue here. Okay, and then this is sort of our winning or terminating condition here, and then we just break out of the loop indefinitely when we find I. Okay, if it's useful for you just to prove that this is in fact working, we might want to print out the index at the end just so you can see that we are terminating early, you know, at the first character. So M is the 0th character, I is the first character, that we indeed find I. Okay, so that's break and continue. And these might be some examples of where you use them for early termination and how to terminate a loop. And again, if you have multiple loops that are nested, you can play around with this as an exercise and have break within one of the loops so you can see what happens in that case. All right, folks, with that said, this lesson's gone on long enough, but now you know everything about loops, for loops, while loops, do loops. We'll get into for each later on. So again, make sure you subscribe so you don't miss that. And if you're an expert programmer, this is probably very familiar stuff to you. So, you know, just know that D has the same facilities available if you're used to C, C++, and Java as far as using these things. And we've got a couple other cool things with working with ranges, for instance, that'll come up here. And if this was new, hopefully you liked it. If you have questions, make sure you comment below. And I hope you're enjoying programming in D, and we'll see you in the next lesson.